The Finley Holiday slide cassette program that you're about to see and hear is the first of its kind ever made available to the public and is a new high in audio-visual entertainment for people of all ages. It is very simple to use. Please follow these instructions. First, place your slides in the projector and advance to slide number 1. Then, each time that you hear the tone, advance the slide. It's as simple as that. So now, sit back and let's enjoy the show. The mysterious red star known as Mars has proved over the centuries to be man's most elusive quest. In all the star-filled heavens and in the study of celestial bodies, none has offered such mystery, such intrigue, and so many unanswered questions. For thousands of years, man has associated Mars with monsters, war, terrible green warriors with 6 limbs, great canals, vast civilizations, and towering cities. So it is reasonable that one of man's great dreams has been to reach that very distant and elusive planet. But despite these dreams and man's efforts, each question answered has caused countless new questions to be asked, questions that, up until now, could only remain unanswered. But this was to change dramatically after 14 years of planetary exploration by unmanned spacecraft. An unrivaled new concept emerged, an amazing new spacecraft which blended the scientific knowledge of today with the ingenuity of tomorrow. A hybrid craft of staggering potential, they named it Viking. Where once sturdy seamen and valiant explorers risked their very lives in a quest for glory and wealth, it now became possible to dispatch an automated, self-powered laboratory 440 million miles through space, soft-landed at a chosen spot on an alien world, and then commanded to conduct and report on subtle biological, chemical, and physical measurements designed to answer those questions that have plagued man for hundreds of years. This, then, is the story of that spacecraft called Viking, and its incredible journey to a far distant portion of our solar system to conduct a detailed scientific examination of the planet with its primary goal, a search for life on Mars. 2 identical Viking craft were built and launched. Viking 1 was lifted by a Titan Centaur rocket from the Cape Canaveral Air Force Station on August 20th, 1975, on a 10-month journey through space to Mars. Viking 2 followed on September 9th. The Viking spacecraft is the most versatile automated explorer ever built. Each craft consists of an orbiter and a lander capsule weighing a combined 7,760 pounds. The Viking 1 orbiter is the second American satellite to explore Mars from orbit, examining the planet's surface and atmosphere with several instruments and producing a great number of wondrous photographs that have startled scientists here on Earth with their clarity and detail. The capsule underneath the Viking orbiter contains the spectacular Viking lander. The data from the lander is transmitted back to the orbiter and then to Earth. The large dish antenna is used for the orbiter-Earth radio link. With Project Viking, the United States, through NASA, undertook its most comprehensive scientific exploration of another planet. 72 prominent scientists, forming 13 teams, pre-planned dozens of complex scientific investigations to be carried out by 9 sophisticated instruments aboard the lander and 4 on the orbiter. The focal point for all flight operations was the Jet Propulsion Laboratory, operated by the world-famous California Institute of Technology. Here, members of the scientific and engineering teams programmed and controlled the 2 Viking spacecraft. It is little wonder early astronomers guessed Mars to be a second Earth, because of the many similarities of the 2 planets. Even with today's knowledge, we still consider Mars more Earth-like than any of the other planets. It is the 4th planet in order from the Sun. Earth is the 3rd. Mars, like Earth, has seasonal changes. Clouds form and dissipate. Great windstorms sweep the surface. It is smaller, 4,230 miles in diameter, compared to Earth's 7,926 miles. Mars' days are 24 hours and 37 minutes. This rotational period is called Sol by the Viking engineers and scientists. In this color photo taken as Viking 1 approached Mars, we see the prominent features of the Grand Canyon of Mars near the top. At the bottom, an extensive area of frost, and at the top, a large white area of clouds. Just below the center, near the terminator, is the large impact basin, Argyre. This spectacular view was taken as Viking 1 closed to 348,000 miles of the planet. Clearly seen here are the Tharsis Mountains, the row of 3 enormous volcanoes standing about 12½ miles above the surrounding plains. Olympus Mons, Mars' largest volcano, is toward the top. Faint, light, curved bands in the lower half of the picture are thin, cirrus-like clouds. As Viking approached yet closer to Mars, it took this exciting picture of one of Mars' 2 moons, heavily cratered Phobos. The large crater near the North Pole is approximately 3 miles across, while craters as small as a few hundred yards can be seen. The diameter of Phobos is about 14 miles. From 19,200 miles above the surface, Viking Orbiter 1 took 15 black and white photos through 3 color filters, violet, green, and red, to form this color mosaic of part of the so-called Grand Canyon of Mars. This largest natural feature discovered so far in our solar system averages 250 miles across and would stretch from San Francisco to New York. Its length, 3,100 miles. This is one of the most remarkable orbital views of Mars yet obtained. It is an oblique view across Argyre Planitia toward the horizon some 12,000 miles away. On this day, the Martian atmosphere was unusually clear, and craters can be seen nearly to the horizon. The curve of Mars is plainly visible, and above the horizon are detached layers of haze 15 to 25 miles high, thought to be crystals of carbon dioxide, or dry ice. Another view of the enormous canyon, Valles Marineris, which cuts deeply into the surface and stretches nearly a third of the way around the planet. The principal canyon crosses the bottom half of the picture. The far north wall shows several large landslides, probably triggered by Mars quakes. A maze of channels at the bottom may have been cut by groundwater or other less understood processes. Mariner 9 disproved the long-held theory that no appreciable amounts of water had flowed on Mars during its past. However, it remained for Viking 1 to reveal that water had, sometime in the past, flowed in enormous quantities across the surface, cutting immense canyons, channels, and leaving islands and preponderous amounts of debris at channel mouths. Some erosion lines indicate rivers of more than 100 miles across. In this photo, one such channel can be clearly defined. A shoreline is plainly visible on the right. A Viking photo from orbit established the first visual detection of an interchange of water between surface and atmosphere on Mars. Each of the major craters seen here have their floors covered with morning fog. A slight warming of the sub-zero surface by the rising sun evidently has driven off a small amount of water vapor, which has recondensed in the colder air just above the surface. The great Martian volcano Olympus Mons is the largest mountain so far discovered in the solar system. It was photographed by Viking 1 from a distance of about 5,000 miles. The 15-mile-high mountain is seen in mid-morning, wreathed in clouds that extend up its flanks to an altitude of 12 miles. The giant crater is some 50 miles across and appears in this view to be cloud-free. The cloud cover is heaviest on the far western side of the mountain, and a well-defined cloud train extends several hundred miles beyond the mountain. The clouds are thought to be composed principally of water ice, condensed from the atmosphere as it cools, while moving up the slopes of the enormous mountain. The base of the great peak would extend from Los Angeles to San Francisco. Viking 1 was originally scheduled for a 4th of July landing near the Martian equator in the Chryse area. to climax America's bicentennial celebration. However, after careful, detailed study of the landing site, it was declared to be too dangerous, and a new landing site was selected in the Chrysi-Planitia Basin, about 820 miles north of the equator. Then, the long-anticipated moment arrived. At mission control, everyone held his breath as the Viking lander capsule dropped from its protective cradle below the Viking orbiter and approached Mars at over 10,000 miles per hour. Reaction controls automatically positioned the capsule so that the heat shield would have the proper attitude for entry into the Martian atmosphere. At 19,000 feet, the descent was down to 560 miles per hour, and the protective shield was jettisoned. Then a large parachute slowed the descent to about 145 miles per hour. It too was then jettisoned, and the amazing descent propulsion system took over and lowered the craft gently to the surface at 5.5 miles per hour. This simulation shows us what the scene may have looked like shortly after the landing, with a life search lander in its discarded capsule sitting on the surface, while the orbiter continued its flight far above. The 4 orbiter panels supply solar electric power. The white blanket protects the craft's rocket motor from the sun. The circular antenna points to Earth. But now the moment of truth. No one stirs as the anxiously awaited image begins to take form on the monitor. And then, there it is, the first picture ever taken from the surface of Mars. An astonishingly clear photo of an arid, strange new world, a geological heaven. It was obtained just minutes after the craft successfully landed. The center of the image is about 5 feet from the camera. We see both rocks and finely granulated material, sand or dust. Many of the small rocks in the foreground are flat, while several large rocks exhibit irregular surfaces with pits and linear cracks. The footpad appears at the right. This is the first color photo transmitted the 220 million miles from Mars back to Earth on the day after the landing. It is about noon. Orange-red surface materials cover most of the surface, apparently forming a thin covering over darker bedrock exposed in patches in the lower right. The sky has a pink cast due to the scattering and reflection from reddish dust particles suspended in the lower atmosphere. The technique used in obtaining color photos from Mars ensures the accuracy of the colors. 3 days later, Viking's camera captured this dramatic view looking to the southeast over the Martian plain. A zone of large boulders can be seen in the distance. What appeared to be sagebrush in the far distance proved to be just large dark rocks upon close examination. This famous photo brought exclamations of surprise from laymen and scientists alike. For there, on the extreme left, plainly etched on the surface of a large rock, was either the letter B or the figure 8. Did the Martians use our alphabet, or had that elusive fellow Kilroy been here? Well, the answer proved to be not quite that exciting, for it is believed now that it is an illusion caused by weathering processes and the angle of the sun. The object at the lower left is the housing containing the surface sampler scoop. This color image was taken about 15 minutes before sunset on the evening of August 21st, 1976. The low angle of the sun has accentuated the various geological formations. A depression is seen near the center of the picture which was not evident in previous pictures. The rocks just beyond are about a foot across, and the horizon is about 2 miles distant. Toward the horizon, several bright patches of bare bedrock are visible. The prominent features visible in the photos, such as rocks, have been given pet names by the scientists and engineers at JPL, such as the Midas Muffler Rock and the Giant Shoe. The largest rock visible in the Viking-1 area is Big Joe, seen here. This large 3 by 10 foot dark rock has a topping of reddish fine-grained silt that spills down its sides. Big Joe appears to be sitting on a rim of an ancient crater. Drifts of reddish sand cover the surface to the right and left of Big Joe. The part of the lander that is visible is the cover of the nuclear power supply. One of the most exciting photos of the Martian landscape to emerge from either Viking 1 or 2 is this, showing a beautiful dune field with features remarkably similar to many seen in the deserts of Earth. It was taken early, 7:30 in the morning Mars time. Viking scientists have studied areas very much like this in Mexico and California. The sharp dune crests indicate the most recent windstorm capable of moving sand over the dunes was in the general direction from upper left to lower right. The large boulder at the left is about 25 feet from the spacecraft and measures 3 by 10 feet. Viking's remarkable pair of cameras has produced images with extreme detail thanks to computer enhancement. Their range gives them a sweep of the entire horizon around the craft, 360 degrees. This picture revealed rocks in a field which range in size from several inches to 13 feet wide. Geologists believe that the reddish surface color of Mars has been produced by a chemical reaction between iron in the planet's soil and water or water vapor in the atmosphere. The process is the same as rusting on Earth. The flag of the United States and our bicentennial seal rest proudly on the surface of Mars. In the foreground is the Viking lander. Within the flat-topped container is the seismometer. The view is west of the spacecraft and includes a series of low hills. The blocky hill in the center is believed to be part of a crater rim. The dark, rocky stripes may be material ejected from the crater. The light areas are dune-like and may be accumulations of wind-blown sand or dust. On Sol 8, the 8th Martian day after the landing, another anxiously awaited moment arrived. A fabulous mechanical arm extended about 10 feet from the landing craft and with a jerky motion scooped up a handful of Martian soil. Then, quite slowly, it retracted, swiveled, and delivered its prize into a set of hoppers atop the 7-foot lander. Preparatory to the soil recovery, an amazing computer generated these grid lines on the imagery of the Martian surface to outline possible sites for that first soil sample. The object on the left is the craft's meteorological station. The weather report for July 20th, 1976. Light winds from the east in late afternoon, changing to light winds from the southwest after midnight. Maximum wind, 15 miles per hour. Temperature range, minus 122 degrees Fahrenheit just after dawn to minus 22 degrees Fahrenheit in the afternoon. Pressure steady at 7.70 millibars. To the left in this view is a small dune of martial material left by the trenches dug by the surface sampler. The sampler scoop is seen in its parked position. The Martian surface is strewn with a variety of angular rocks of various sizes, shapes, and types. This image shows the main trench excavated by the Viking sampler. The trench was dug by the thrusting of the collector head into the surface material, then withdrawing it. The doming of the surface at the far end of the trench shows the granular material is dense. It behaves somewhat like moist sand on Earth. The results of the life determination experiment aboard both landers were still open to speculation several months after the landings. The results from the many various life detection experiments aboard were very puzzling, some indicating life, perhaps in some strange form, while other results indicated no biological activity whatsoever. On August 7th, Viking 2 approached Mars to join Viking 1 and produce another remarkable achievement for unmanned United States space exploration. On September 18, 1976, the Viking 2 orbiter obtained this startling photograph of a portion of the surface of Mars' inner moon, Phobos. It has been photographed hundreds of times, but never at this range, 545 miles, or with this resolution. Smallest objects visible are 130 feet across. At this close distance, Viking's TV camera was moved at a speed to match the movement of the moon, otherwise the image would have been badly blurred. The result? A very sharp image that reveals about 1/2 of a craggy oval that measures about 10 by 14 miles. The moon, as expected, was heavily cratered, but surprisingly, shows numerous striations, which at this time cannot be satisfactorily explained. Note the central peak in the crater at the bottom. On August 30th, the Viking 2 orbiter took these overlapping pictures from a distance of 2,480 miles of the North Polar region as midsummer approaches in the northern hemisphere of Mars. The melting polar cap has receded to its smallest size. The solid white areas toward the top are mainly water ice. The dark bands which spiral in toward the cap's center are regions devoid of ice. One of the most exciting and spectacular photos ever to come from space is this view of the North Polar region taken on October 4th, 1976. It shows a great ice-draped cliff near the edge of the North Polar cap. Dark areas are regions where the ice is melted. White areas are ice. Viking's experiments have helped to confirm that the residual polar caps are composed of water ice and not frozen carbon dioxide as previously thought. The photos of this northern region have also revealed an enormous band of giant sand dunes that encircle the entire polar cap. They may indeed prove to be the largest dune field in the solar system. They may be composed of deposits of dust that have settled into the ice of the pole for over hundreds of millions of years and then were subsequently deposited in great dunes when the ice melted and reformed during huge climactic upheavals that apparently have occurred at intervals in Mars' past. On September 3rd, another anxious moment, and then the thrilling climax as Viking 2's lander settled gently to the surface of Mars' utopian plains, lying between 40 and 50 degrees north latitude. The choice of the Utopia region was prompted by an examination of a number of photographs of the Cydonia and Arcadia plain sites, which indicated that neither was suitable for locating a safe 137 by 62 mile landing area comparable to that used by Viking 1. Here we see the lander's footpad and many pitted, eroded small rocks. The one nearest to the pad appears to have been overturned and pushed away by the craft. The landing pad itself is covered with dust caused by the landing rocket blast, and it may have been damaged in the landing. Viking 2 is located 4,600 miles to the northeast of Viking 1. On September 5th, the first color photo from this lander was beamed back to Earth. It revealed a scene dramatically similar to the Viking 1 area. Rocks and boulders covered with drifts of Martian reddish sand everywhere. Because the craft landed on an 8-degree tilt, the horizon appears tilted, whereas in fact it is nearly level. A utopian bright summer afternoon on Mars with a temperature near zero. Hardly what we here on Earth would think of as a midsummer day. The reddish surface is strewn with rocks, some as large as 3 feet. Many of these are porous and sponge-like, similar to Earth's volcanic rocks. Others are coarse-grained, such as the large one in the lower left. A portion of the spacecraft appears in the lower right. On a clear day on Mars, you can see forever, and also tens of thousands of rocks. The horizon is about 2 miles distant. What appears to be a small channel winds from the upper left to the lower right. Shining on the surface near the Viking 2 craft is the aluminum shroud or cover which protected the collector head of the surface sampler during Viking's year-long journey from Earth. In preparation for the life detection and soil analysis experiments, this cover was ejected by a set of 8 springs. The large rock in the foreground is about 2 feet long and a foot thick. Now another moment of high adventure is reached as the Viking 2 sampler began its soil recovery procedure. In this series of 4 photographs, the sampler first positions itself at the far end of the projected trench. In the second of the series, it is withdrawn and repositioned to sample the desired point, and in the process, raking the surface and breaking it in preparation for the thrust into the soil, as seen in the third photo. In the last view, we see the foot-long trench, which is about 2 inches deep and 3 inches wide. At the Viking Mission Control and Computing Center, 3 sets of giant computer systems send, monitor, and process data from the orbiters and landers. In addition, another system of IBM 360/75 computers display in real time all the images and telemetry data from the landers on the surface. This composite of three-color photos stretches across nearly 200 degrees. Most of the rocks are coated with rust-colored fine-grained material. As Old Sol rises over the bleak Martian plain early on the morning of July 26th, it appropriately catches Viking-Mars lander with the American flag and bicentennial symbol. This nostalgic scene forcefully brings to mind the vast accomplishments of the Viking project and its personnel, whose technical skill and dedication made this one of the greatest scientific accomplishments of all time. What better way to end this story of tremendous achievement than with a Martian sunset over the plains of Chrysi-Planitia? For 11 long, worrisome months, they whirled through the corridors of space, silvery, squat machines bent on a nearly impossible mission of 1/2 billion miles. Yet that mission was accomplished with such ingenuity, such skill, that it appeared to most people to be routine. But it was far from that. And perhaps men in the far distant future will look back and fondly remember that grand and glorious time when the Vikings explored Mars. Your Bi-Media program is now complete. Please rewind this tape and you will be ready to enjoy it again at your next showing.